In today's video, we're going to take a look at smooth scrolling and raster bars. Let's get right into it. I'm going to close off all the other windows first. I've increased the font size because you asked me to. I will be using C64 Studio, a GUI interface, which allows you to create 6502 code in a text format, text editor format, and then you can output it to CCS or WinVice. And the format is star equals, and then the start address of where you want to put the code. So we will be going to File, New, ASM file, because it's an assembly file. And let's just get into it. Star equals 1000. That tells the assembler where you want to put the code. I'm just waking up here. Start address. All right, now, on the 64, there's a chip known as the 6502, and there are pins on it. There's A, X, and Y. And you can think of it like a traffic cop at an intersection. And if we want to load A with 0, we put LDA number string 00, and that puts a 0 on that pin. I like to use the analogy of an envelope. You have an envelope on your desk with an A, an envelope with an X, an envelope with a Y. And you can think of it just like a variable in BASIC or an envelope, whatever analogy works for you. But we're going to put 0 into the A envelope or put 0 onto the A pin of the 6502. And then we're going to say store A in D020, store A in D021, and depending on which analogy you want to use, the 6502 sends that out like a courier truck down the line to location D020, which is the border 53280. And then it sends out another courier truck and puts the delivery of 0 into D021. Or if you use the analogy of an envelope, the envelope gets delivered to this address and put into memory. So we have now taken 0, put it into A, and stuck it in the screen colors. We use the format number $. We always use $, because that indicates hex. Number means we want that true number. The difference being, if I was to put load A with 00 without the number sign, it's going to load whatever is in location 0 instead of the actual number 0. So just remember, number means the actual number. I believe you are already familiar with the FFD2 routine. I never quite remember if it's 92 or 93. I think it's 93. We put 93 hex into A, and then we call FFD2 by the JSR function. So that means jump subroutine, go to this routine in the 64's kernel at FFD2. This is a ROM routine. You can't erase it. You can't change it. And it prints whatever is in A. We're going to run it. SYS 4096. All right, it has cleared the screen and set the colors to black. Perfect. Next, let's see. I'm trying to think of the best way to do this. Let's do a title page. So you can customize this as you see fit. I'm going to introduce you to something that's going to save you a lot of work. We're going to put intro. That will be our label. And then exclamation mark, text. Welcome to my new smooth scroll routine. And we can put a carriage return in the form of a byte 13. We use exclamation mark text to indicate that we're putting it, excuse me, we use exclamation mark text so it knows that this is to be just text put into memory, and this is to be an actual byte 13. In hex, that would be 0D. I hope you like it. And then we terminate it with a byte 0. And instead of making a routine to print this custom text, there's actually a built-in routine. Load A with the low byte of intro. Load Y with the high byte of intro. And then JSR AB1E. I will put that routine up on the screen for you. This has not been tested. We're going to see if it works. And what AB1E will do is it should put it in uppercase. So we need to change text to SCR, screen text, screen code. SYS 409, oh, and it converted it. I see. We have to do it in caps. So we'll use exclamation mark SCR and caps. If we use lowercase, then it treats it as color codes. There we go. This should work. Take 3. Welcome to my new smooth scroller. I hope you like it. We'll add 2 consecutive returns to put a bit of spacing. In C64 Studio, we can put color codes in curly brackets. So white, and then we'll put, I believe pink is another one we can use. It might be light red. I can't quite remember. There we are. We'll dig into the source code here. The assembly code. This is our clear screen routine. Load A with 15, load Y with 10. So Y is high. Just think of that little rhyme. Y is high. A is 15 in hex. So that gives you 1015. And if we look at 1015, that is our text. There is the character code for white. JSR AB1E, which will print our text. This is a routine that's built into the computer. It's not something that I have made. So you can adjust this as you see fit. I believe the limit is 255 characters max. It could be 256, I'm not sure. But if you put too much text and then you run it and it doesn't work, that's because you exceeded the limit. And terminate it with a 0, otherwise it falls through and prints whatever is after this. It needs to know when the text is finished. I think I've gone at a slow enough pace that you should be understanding this, especially if you've watched my previous videos. The next step is we're going to get into the interrupt. So we're going to set interrupt disable. And what that does is it stops the computer from processing interrupts in the background until we make some changes to the system. 60 times a second, your computer is doing updating tasks in the background. It flashes the cursor, it updates the time clock. There's a whole bunch of things going on in the background, and you can tap into that. I've covered this in previous videos. I will do it again really quickly, just give you a crash course. I'm not going to go full in-depth into how interrupts work at this point. I've covered it in previous videos, but you should know that location 0314, 0315 are the pointer or vector, if you want to refer to it as such. EA31. The first value is the low byte, second one is high, so it's written like this. EA31 is all of the routines it does in the background, updating the time clock, flashing the cursor, etc. So we can tap into that the same way you can tap into water supply in your house if you're putting in a new bathroom. You can tap into your 12-volt system in the car if you're putting in an accessory. We can tap into it. So instead of it going to EA31, we send it to our routine, and then we send it to EA31, and it continues on its way. We're just tapping into it. To do that, we can assemble some code anywhere to do what we would like it to do. Increment the border color. Increment the screen color. This is what we want it to do in the background. We have to send it back to its original course of action so it continues to flash the cursor and do all of its stuff. We're just inserting a few extra things before we send it off to what it would normally be doing. And if we change those pointers from EA31 to 033C, it will now go here instead and then continue its routine. So now it's increasing the border and screen colors while still flashing the cursor and still updating the time clock, amongst other things. So that's why we need to disable the interrupts temporarily. We want to make some changes to it. So we're going to load low byte of the IRQ, store in 0314, load the high byte, put it in 0315. IRQ has not been defined yet, so do not panic. We're going to load number $30 and store in D012. We're going to CLI, which means you can safely resume your interrupts, and RTS, so it goes back to basic. Now what we have to do is load A with 1, store A in DCOD, then store A in DO1A. I'm trying to put it in caps here. And the reason for that is that putting 1 in DCOD turns off the CIA timer interrupts, and putting it in DO1A enables VIC Raster interrupts. The 64 generates a raster beam that draws the screen line by line from top to bottom. And what we want to do is we want to disable the CIA because it normally generates timer interrupts. And so we want to turn that off so that it doesn't interfere with our VIC interrupts. A timer interrupt would be if you wanted to have, for example, a clock that was accurate to the time of day and show it on the screen. We don't need any of that right now. We just want precision VIC raster interrupts on the VIC chip. So when it draws the screen, we want to be able to intercept at certain positions of the screen and have it do our own custom code. It's probably not all that clear, is it? But we've redefined 0314 and 0315, and we've set 30 as into DO12. So what that is going to do is it's going to say, when the raster bar reaches line 30 in hex on the screen, we want you to fire our routine. You can think of it like a man on a scaffold, and he's painting. He's painting the screen, and he starts at the top, and he works his way across, and he moves down a row, does the next, moves down a row, and when he reaches the bottom, he comes back up to the top. This is happening 60 times a second. Too fast for a human, but not too fast for the VIC register. So we put a value of 30 in DO12. We say this is where we want you to fire our IRQ routine. I'm going to put a decimal number because I'm not sure what the hex would be in 53270. 53270 is also known as DO16. We use it to shift the screen over by pixels. If we want to move the screen over 1 pixel, we put a value in D016. It also controls multicolor character mode, and I will put a little image up on the screen to show you. What we're doing right here is we're just setting the screen to be stable, not moving, not multicolor, just stable, so that it can show our intro message. And that's all we're going to do at this point in time. That's all we're going to ask of this little interrupt. Then we're going to chain the interrupt. Why are we chaining an interrupt? What is chaining an interrupt? I'm going to explain this to you as soon as I'm done typing. What I'm doing is I'm creating one interrupt and saying fire when you get here. And then I'm reassigning a value to 0314, 0315 and putting a new value in D012 so that as it continues down the screen, painting the screen, updating it, when it hits 83, because we put 83 into D012, it's going to fire IRQ 2. That's known as chaining them together. I am using EA81 instead of EA31 because EA81 is simply exiting the routine. It's exiting the interrupt. We want to get in and out as fast as possible. We don't care about flashing the cursor or updating the clock at this point in time. We want everything to be laser precise as it makes its way down. We want those raster bars to be smooth. So we're just going to go to EA81, get in and out of that interrupt as fast as possible. And for the final interrupt chained together, we're going to call EA31 so it can do the housekeeping tasks that it requires. Some of you are probably scratching your head. One other thing that I forgot to do is to put a value of 1 in D019. That lets the computer know that we have actually created the interrupt, we have fired it. Otherwise, it's going to continue to attempt to fire this interrupt. It's a way of saying, okay, we've actually processed this interrupt. It's done. So I'm going to repeat the process, putting a 1 in location D019. And then I'm going to introduce some custom code. That custom code is right here. We're going to load Y with 0. We're going to load Y with, we're going to load X with 0, sorry. And then we're going to load Y with color bar 1, comma X. We're going to load D012, compare it to D012 if it's branch equal. This is code that I have already created. That's why it has existing labels. So I should actually be explaining it to you, and I will. We acknowledge the second interrupt. We set X to 0, and we're loading a series of colors from a label known as color bar 1, which has not been defined yet. So let's do our colors right now. It is case sensitive, so color bar 1. I'm going to put 9, 8, 7, 1, 0. And because it is case sensitive, I have to change this. So it's going to grab the first color, which is 9. And this routine here is very specific. We load A with whatever is in D012, the raster bar making its way down the screen. And then we immediately do a compare D012, which might be a little hard to understand. Why are we doing this? So let's say it's on line 83. It will put 83 into A. Then we immediately compare what's in A with D012, which should be an 83. And because we have branch equal, it goes back up to the negative, to the takeaway sign. This is a label. We can replace it. Minus sign is the same thing as a label. Wherever it sees minus, if I put a minus here, and then I say jump minus, it goes up to the nearest minus sign, whereas plus moves in the opposite direction. We can get into that in a later video. I'm probably losing a few of you. So we set X to 0. We take the first color from color bar 1. We load DO12, which is the raster. We want to compare it to itself, and if it's equal, go back up and wait. We want to wait because A is not going to change. It's already set to 83. We want to keep checking DO12 until it finishes moving over and goes down to the next line, so it's no longer equal to what it used to be. Now it would be 84. The idea is we don't want the painter to start painting new color when it's halfway across the screen. We want to wait till the raster is at the start of a new line. And then we store Y, which has our color, into DO20, DO21. We increment X, compare X to 5, 0, 1, 2, 3, 4. We have black as the last color. Because the screen is black, we want it to continue painting black. Branch not equal. I have to change my old labels. I apologize if you're just copying and pasting this. And that will go up here to loop. That completes our second interrupt. It has done what we wanted it to. So now I will load the original IRQ back. I'm terrible with upper lowercase. Put 30 back in DO12 and jump EA31. I just want to see if this works before I get into explaining what it's doing. And it just totally crashed. Okay. We have to figure out what's going on here. But we now have a working raster. What was wrong? There's one thing I forgot to do, and that is put 1B in D011, because the raster register is actually made up of 2 locations. Because there are more than 256 scan lines on the screen, there's also the high bit. So always set D011 to 1B. And then I'm going to compile the code. To compile it, I press Control F5. We're going to SYS 4096. And we have a very, very smooth raster bar. If you go up to Build, it's Build and Run, also known as Control F5. That is how you compile the code. You have to configure C64 Studio to first run either WinVice or CCS, which is done from the Setup Wizard. I'm hoping that you're a little bit familiar with C64 Studio. I'm going to go over it. I'm going to try not to go over it too many times. I tend to repeat myself. We set the border and screen to 0. We clear the screen. We're using AB1E as a new routine to print text, where A is the low byte, Y is high. SEI, we want to stop the interrupts temporarily. Put 1 in DCOD because we don't want the CIA timer interrupts. We want VIC raster interrupts. So we put 1 in D01A. We define 0314 and 0315. By define, I mean we're putting in the values of the new pointer to our IRQ, which used to be, of course, 31 and EA. Then we say we want you at location 30 on the screen. When DO12 goes down, and it hits 30, which is roughly the top of the screen, we want you to fire the IRQ. So what we do is we acknowledge that the interrupt has happened. Otherwise, it's going to continue to keep trying to fire that routine. We're going to set the X position of the screen, because you can shift the screen left and right by up to 8 pixels, I believe, 7 or 8 pixels. We want it to be stable, not moving, because we are going to introduce a smooth scroll. And then we want it to fire the second routine, IRQ2. So we take the low byte and again define it in 0314 and define it in 0315. Or I guess I should say store it in 0315. And then 83 is the position of the raster beam where we want the second IRQ to occur. Again, we acknowledge the interrupt. We set X to 0, and we start taking colors from color bar 1 using X as the offset. This is very important. We load A with DO12, the raster beam going down the screen. So it's in A already, the current value, which should be 83. And we just compare 83 with DO12. And that's why it's in a loop, branch equal, branch equal, branch equal. We're waiting for it to finish drawing and coming down to a new line, because we want those raster bars to be smooth. And then we take the color Y and we store it in DO20, DO21. Increment X to get another color. Is X equal to 5? No. Go back up to loop. And then when it's finished, because we have a 0 here, if I don't have 0, I will show you what it does. It will fill the rest of the screen up with white. See that? It's not very attractive. So we want it to continue drawing 0 black. And then what I've done is I've redefined the pointer to the original IRQ. So it's chaining it. We first set it to IRQ, which fires and just does this. We redefine the pointer to IRQ2, which does this. And then we're putting it back to the first IRQ. So we've chained 2 of them together. Interrupt 2. What do you think comes next? Well, what comes next is we're going to load A with something called PIX and store it in 53270, which is DO16. We're going to change. We have the screen nice and stable here, but we do want a smooth scroll. So we're going to start changing the X position of the screen. We haven't defined PIX yet. PIX is going to be a byte C7. And then I'm just thinking how to proceed. I'm going to now make it fire a third routine. And the third routine, if you just give me a moment, will be at line, let's put it at B3. I'm going to just do a little bit of maintenance here. I'm going to make it a little bit more readable. Interrupt 1, interrupt 2. This points to interrupt 3. Interrupt 3. So we've told it to go to interrupt 3 for line B3. And this is going to be essentially the same thing as the code above it. And I will explain why in just a moment. So IRQ3, we're going to put a 1 in D019 to let it know that we have acknowledged the interrupt, which apparently I already did. And then we are going to load X with 0, load Y with color bar 2. I'm going to create another color bar. Color bar 2 is going to be the same colors, but in reverse order. So 1, 7, 8, 9, and 0. You'll see why when it displays on the screen. We have to change the label. We cannot have duplicate labels, so we're going to repeat the process of checking DO12, waiting for it to be on a new line. Have we reached 5 colors yet? If not, go back up to loop. I'm not sure if this is going to work. The code is not complete yet, but I'm just curious. We have the bottom color bar. Do you see what I mean about reversing the order of colors? The reason it's not working, of course, is that we haven't set the IRQ back up to the top one in the course of chaining them together. So we have to tell it to go back up and start the process again, which fires on line 30, and now we go to EA31. So just for those who are confused, we've set up the IRQ line 30 of the raster line. When the raster beam hits 30 hex, it fires this routine. We've now said we want you to go to IRQ2 next time when you hit line 83 and just exit via EA81, which is just a quick way of saying get the heck out of here. And then for IRQ2, we draw the color bar. We go to IRQ3, which we want to happen on line B3, raster beam line B3. Get out of here as quick as possible. And then IRQ3, we draw the lower color bar. Because we're done, we're not worried about laser-specific timing. We can now jump to EA31 to flash the cursor, update the time clock, and all of the other stuff, because we're done with all of the precision timing. And this should work. We have 2 very smooth color bars. And you'll notice the screen is in 40 character mode here, but when we get down to the smooth scroll area, the left and right side of the borders are not showing. That's because we've put the screen into 38 character mode for here, because you don't want to see the characters leaving the screen on the left or right side. It's not smooth. You can see them just popping in and off. So I'm going to show you. I think I did this in a previous video, but I'm going to show you. So here's 200 in DO16. It's just a normal screen, which is what we've done in the source code right here in the first interrupt. We just have a normal screen. We can, however, go to 199, and you'll notice now that it's a 38 width screen instead of 40. And then we can go 198, 197. It's like the old televisions that had the dials in the back with the horizontal and vertical controls. If you're younger than 30, you probably don't know what I'm talking about. But we can adjust the left and the right positions. So keeping that in mind, when the raster comes down the screen, we can put it into 38 column mode. And we do that because when characters are scrolling off the screen and they're coming on the screen for a smooth scroll, they're just going to suddenly pop on and suddenly disappear off. So when we put it in 38 character mode, it's like putting a piece of paper over the border so that you don't actually see them coming on and off, and it makes it look smoother. So that is why we're using 38 character mode. So C7 is what we've defined pix as. I call it pix because we're moving over pixels one at a time. We're going to put the screen into 38 character mode, which is already done right here where the raster, you see how the cursor moves over? It's gone into 38 character mode. This is 40, this is 38. And now what we have to do is just shift the screen over line by line, pixel by pixel. So to do that, I'm going to create a routine called scroll. And that is I'm just going to take some code I have prepared. Scroll. All right, so decrement PIX. Load PIX. Compare it to C0. Branch not equal exit. Otherwise, put C7 in PIX. This is a pain in the ass sometimes, this case-sensitive labels. So we're going to take C7, which is in PIX. We're going to decrement it. So it becomes C6. Has it reached C0? No. Go to exit and just return. And then if it does hit C0, it's going to go back up to C7. So it creates a loop where it falls from C7 down to C0 and keeps looping. And if it compiles properly, and it has, okay, perfect. So you can now see the screen is shifting over. The top half is not because we've put 200 into 53270, but here we've told it to keep shifting left from C7 to C0. It's not really moving, it's just shifting the screen. It has the appearance of actually moving. If you look at it, I'm not sure how it will appear on the final video, but if you follow it with your eye, it does appear like they are smooth scrolling over, but they're not. The screen is just shifting. See what I mean? If you look at the non-equal characters, non-similar characters, that's the first step. So we were going to put scroll text and then exclamation mark SCR because it's going to be screen text. Welcome to my new demo. This should appear very smooth. And we're going to just put some spaces so that the text can scroll off and scroll back on. We terminate with a byte 0 because we want to know when the scroll is finished. So to do that, we check for a 0. The next step is to find out what line we want the text to appear on. So that will be, let's put it right there. I'm going to go into the monitor and just find out where those S's are on line 0608. So right here, when we've moved over as many pixels as we possibly can, we're going to load X with 0. I'm going to load 0609, X, store 0608, X, increment X, compare it to 39 decimal. Branch not equal, loop 3. What this does is it sets up a loop. It will copy, well, I'll explain it once it's actually working. I want to make sure that it works first. Okay, so we go down here and it should. There we are. It is now smooth scrolling text. So the way that works is we take what's at location 0609. I'm going to bring up the screen again. It would be easier to explain it to you. So 0608 will have a 060B will have a B. Here's what we're doing. We're loading 0609, which is right here, comma X. X is 0, so it's not going to apply any offset. And it's going to copy it to 0608. So the B moves there. We increment X to 1. So when we load 0609, comma X, it moves over 1 because comma X is like saying plus X. And it stores at 0608, comma X. This is 0608, but because X is 1, so it moves it from here to there. When X becomes 2, 0, 1, 2, it will copy from here to here, here to here, here to here, as X increments. So we're only using these two locations. We're copying from the B down to the first position, position 2 to position 1. But then we increment X, and it changes the offset every time. Thus, it copies the characters over. And that is the smooth scroll. So we have our scroll text, but we don't have any scroll text appearing on the screen. In order to fix that, once we've scrolled everything over 1, we need to put a new character on the screen. We're going to load Y with 0, load A. We're going to use indirect addressing this time, and I'll explain why in a moment. We're going to load BB, comma Y. Compare it to 0. We want to know if it's the end of the scroll. If it is, go to reset. Reset is going to be a routine to load the low byte of scroll text, store in BB, load the high byte of scroll text, store in BC, and RTS. And then at the very beginning of our code, we're going to JSR reset, so it pre-populates BB and BC with the pointers that we want. So now we're loading Y with 0, loading indirectly scroll text. This is like saying load scroll text, comma Y. But what happens is, if we were to put, say I was to put load scroll text, comma Y, and we increment Y every time, when Y hits 255, it will wrap around back to 0 the next time you increment Y. So if your scroll text is longer than 256 characters, it's never going to display past the 256th one. This way, using indirect addressing, there's really no limit to the scroll text, except for how much memory you have. So we've grabbed the character with A. Is it 0? If so, reset. If not, we're going to store at 0608. I'm going to put plus 39. So on the line of the scroll text, plus 39 should put it at the far right, but it's still stuck on the very first character of the smooth scroll. We have to get it to increment. So we're going to increment BB, branch not equal, exit the routine, otherwise increment BC. So it works like an odometer. BB will increment 0, 1, 2, 3, 4, till it finally gets to FE, FF, and when it hits 0, then it will increment BC, the high byte. I know, you're probably wondering, what is he talking about? Oh, welcome to my new demo. This should appear very smooth. It shouldn't be in uppercase. However, we can just put and 63. Welcome to my new demo. We have smooth rasters. We have smooth scroll. This is not scrolling. That's perfect. The bottom of the screen will be scrolling. If you want to put text down here that's stable, then what we would do is we would create a new interrupt, but we may not have to because we have a interrupt that does the actual scroll. Right after the second color bar, we can do that. So we can load A with 200, store 53270, and in a perfect world where code always works, there, perfect. Right after the second raster bar, it sets it back. So you can put whatever you want down here. It might appear a little bit jerky. CCS, the timing can be a little bit finicky. So I'd be curious to hear from people with actual hardware, with the real 64, if it works or not, if it's truly smooth. That's looking pretty smooth to me. And if we want to get rid of the ready prompt, that's easily done. We just change the RTS to, I'll just put OJMPO, so it creates an infinite loop. Everything is running entirely in the interrupt. Okay. Let's do this. For this final color, 0, let's change this. So we're going to make a label right here. I'm going to call it flash byte 0. And we're going to eliminate this 0 right here. This is still the color bar, 98710. I'll show you what it's doing, and then I'll explain what we're going to do to modify it. So it's putting in a 9, an 8, a 7, which is yellow, 1, which is white, and then 0, which is black. And then it's reversing the order, putting 1, 7, 8, 9, 0, so the rest of the screen is black. We've replaced this 0, this area here, with a label called flash. It's still putting in the same colors, but this 0 now has a label attached to it called flash. So I'm going to go down, find out where it does scroll right here. JSR fader. You can probably guess where I'm going with this, right? Fader. So we're going to load X with offset, load color, comma X, store in flash, increment offset, load offset, compare. We haven't done our colors yet, so let's do that now. Color, byte, 11, 12, 15, 1, 15, 12, 11, which are a series of gray. So 0, 1, 2, 3, 4, 5, 6. Branch not equal plus. I told you that we can use plus and minus. So what we do is when we put plus, it's just going to branch down to this RTS. Load 0, store in offset. We haven't defined offset yet. I think we're good. I think I'm forgetting something, but oh, we are forgetting something. And that is, I forgot at the very start of the code to load 0, store in offset, and now it's going to be super fast because we haven't put a delay in. Oh, there we go. There we go. It's not looking quite right, but that's a fader. When I slow it down, it will look much better. So right after the scroll, we JSR to fader. And what fader does is it loads X with offset, which is a 0. So right now it's a 0. We load color, comma, X. So it takes the first color of 11 and stores it in flash. So it puts it right there, which is the final color of the top color bar. And then we increment offset so it becomes 1. Is it equal to 7? No. Go to plus and exit. Otherwise, set offset back to 0. So it's going to continually go 0, 1, 2, 3, 4, 5, 6. And then when it hits 7, it resets. Reason being 0, 1, 2, 3, 4, 5, 6 colors. So on the 7th, reset. I hope you understand that. It's essentially just changing the last color of the top color bar. Increment delay. Load delay compared to 100, branch not equal plus, which goes down to the RTS and exit. We'll set delay back to 0. So we're going to create yet another variable called delay with a value of 0. Increment delay. Load it. Is it equal to 100? Branch not equal to 100. Just exit the whole routine. Otherwise, set delay back to 0 and proceed with the flash routine, which should slow it down considerably. That's way too slow. Let's put something like 6. There. It's still not looking quite right. Let's add a 0 after the 1. 0, comma, and then we'll increase the offset by 1 so that it now flashes down to black, fade to black, so to speak. 11, 12, 15, 1, 0, 15, 12, 11, comma, 0. Well, it's not perfect, but you get the idea. And we can change this, of course. We can put 6, 14, 3, 1, 3, 14, 6, comma, 0, which would be 1, 2, 3, 4, 5, 6, 7, 8. So take the total number of colors, and that's what value you want for the compare. And it should now do it in blue. Yeah, that's looking a little better. Smooth raster, smooth scroll. Perfect. And if you want to add music, I've covered that in a previous video. That's not hard to do at all. I'm not going to cover it in this video, but we can use the Draconis music. At this point of the video, I'm just going to assume that you've watched it. Otherwise, none of this really applies. We set C1000 to a 1. And then right after the call to fader, we can JSR C001. And then if you were to import it from disk, you would put exclamation mark, binary, music, comma, comma, 2, star equals C1000. So it loads music up into C1000. But since I've already have it on the disk, I can just load it from the monitor. And it should, there we are. I'm not sure if you can hear it or not, but music is playing. So this is your very first smooth scroll. You can do things like rotate the colors. You can make the bars bigger, smaller. And eventually we'll get into having it bounce or you can have the scroll bounce up and down. We can also scroll the other way as well. For now, however, we'll leave it. And one final thing, we can shift it into upper and lower case. As you can see, the fix for that is very, very easy. All we do is we put an 8. We print a character string 8. You could also go up here and you could just put load A with number string 08 JSR FFD2. You could do that as well. It just gives it a more polished professional look where when it's running. Oh, yeah, okay, so I have the music. It's running, you cannot shift it. But it's not in uppercase either, so. Load 21, store 53272. We will get into custom character sets in a different video. We don't have to keep it a single one-by-one scroll. Another thing we can do, we can have a scroller that's 2 characters tall. We can have one that's 4x4. We can even have 8x8. But that's a video for another day. So if you've enjoyed this video or have any questions, feel free to leave a comment. This is Milosoft saying take care.